Astronauts traveling to Mars in 2020 must be protected against cancer and other diseases. Therefore, they may receive an injection of millions of robot machines capable of navigating inside their body. Machines programmed to detect and prevent disease. NASA scientists are designing technologies that explore the inner space of our bodies. NASA needs this technology if it is to keep astronauts healthy in the hostile environment of outer space. This exploration will take us further than we've ever been, beyond skin, blood, and bone, to the individual cells that make up every inch of our bodies, right down to the bedrock of life, inside the heart of the cell, to DNA. Every living cell contains DNA, the blueprint for life. Science has known what it looks like since the 1950s. But in the year 2001, technology gave us the first moving image of an individual strand.
Well, if you think of a DNA helix, that's about 5 nanometers in diameter. As we're able to develop new and more improved nanotechnologies, we are able to develop direct capabilities to measure and to interact with DNA. Nanotechnology will allow us to explore environments and situations that we've never been able to do in the past.
What scientists now understand is that the smallest change in the DNA will cause cells to malfunction, which in turn can spell illness or disease.
Something that a lot of people don't realize is that, within a cell itself, a very simple change can have a major consequence.
The smallest change in the cells of the astronauts blasting off to Mars could be fatal. As they leave the protective umbrella of the Earth's atmosphere, they are fully exposed to the fierce radiation of deep space. As they begin their planned 3-year mission to Mars, the sun, which keeps us alive on Earth, becomes a deadly weapon aimed directly at the astronauts. Radioactive particles are shot out from the sun at the speed of light. In the vacuum of space, the astronauts are powerless to protect themselves.
In terms of this galactic radiation, these very heavy metals or particles enter our cells. And we expect that on a trip to Mars, taking 9 months, that every brain cell would actually be hit.
When a cell is hit by radiation, the DNA is damaged. The cell will malfunction and copy itself. Instead of forming healthy tissue, a tumor starts to develop. This is cancer. Cancer cells inside the astronauts would grow for months before a tumor became apparent. The same is true here on Earth. In today's cancer screening programs, to confirm the presence of cancer, there need to be millions of cells. Typically, these are gathered by taking a smear from potential cancer sites, by X-ray, or by taking a small sample of suspect tissue. Carol Dahl has joined Kathy Olson's quest. She believes the answer to beating cancer lies with nanomedicine.
The current approach to identifying cancer cells basically relies on our ability to detect an anatomical change, so change in the actual shape or structure of the tissues themselves.
By the time the physical appearance has changed, the cancer cells have multiplied many millions of times, and the illness has already taken a hold. Because our own bodies make cancer tissue, our own defenses accept it as part of the body and don't attack it. Surgical removal of a tumor causes unavoidable damage to healthy tissue. Non-surgical treatments against cancer poison the entire body. NASA intends to provide the astronauts traveling to Mars with new technology to prevent tumors from developing in the first place. Nanoscientists are coming up with solutions to diagnose and treat cancer at a much earlier stage, using billions of atom-sized particles created in a sudden chemical reaction. Not nanorobots, but billions of particles, which they hope can fulfill some of the expectations for nanomedicine.
These entities might be able to actually identify in a way that you wouldn't even know it was a process ongoing where the cancer cell is and locate it, send a signal out saying, hey, it's here. and then destroy it without any impact on the rest of the normal healthy cells around it.
These entities are called quantum dots. In the laboratories of the Quantum Dot Corporation, teams of expert chemists, biologists, and physicists are investigating the dot's potential. They want to put quantum dots inside living tissue. The dots are so small they can enter cells and be used in a similar way to current chemical markers.
They have potential utilities for us to actually see inside cells. Quantum dots have a number of different advantages to current chemicals that are used so that one can actually see much brighter and stronger signals inside living cells and tissues.
Scientists found these particles could be made to latch exclusively onto cancer cells. Like a beacon, they would light up and offer a very early warning signal of danger. The red glow here is quantum dots, which have hunted out and latched themselves onto cancer. There are millions of these nanoparticles around each cell. As scientists experiment with the quantum dots, they are finding ways to make them react in interesting ways to specific light sources. Dependent on a tiny change in size, the particles will reflect a different color. Walt Mahoney looks forward to the day when his quantum dots can be injected into a patient and begin a fantastic voyage, detecting cells which are not functioning normally. The dots are absorbed throughout the body. When they find what they are looking for, they start to congregate. With a special light shining on them, the dots will give a visual signal by glowing brightly. Standing in the center of a stadium, Walt Mahoney explains just how small a quantum dot is.
If this baseball was the size of a quantum dot, this entire stadium would be a red blood cell.
A quantum dot is many millions of times smaller than a red blood cell. The light they reflect from inside a cell can possibly indicate the presence of cancer. A quantum dot is so small, it can be barely imaged on the most sophisticated microscope systems.
Oh, this is beautiful. We're looking at a single quantum dot. It's actually a quantum dot core, and we're looking at columns of individual atoms. The white bits may be simply the space between the atoms. We should be looking at the black bits as the true atoms. From one side to the other side, it's about 5 nanometers in dimension. So these things are exquisite in geometry and quite beautiful, yet very, very small.
These quantum dots could form a foundation for nanomedical probes protecting astronauts on a mission to Mars. Dwarfed even by red blood cells, the almost invisible nanomedics can patrol the body with ease, gaining access to all areas. In future experiments, the hope is to affect quantum dots in such a way that they will respond to a flash of light and heat up, thus destroying any defective cell they have gathered around, without damaging any healthy cells in the process.
So the concept for the new technology is that if cancer is analogous to a barrel of apples in which there's one rotten apple at the bottom of the barrel, that the nanotechnology would be able to go into that barrel and look around at each and individual apple and identify the one that's rotten based on a signature, whether it's the color of the apple or what's inside the apple, and eliminate that apple without touching the apples surrounding that apple and leaving the entire barrel intact.
Quantum dots are not the only new medical nanotechnology which may be sent to Mars in the bodies of astronauts.